Hello and welcome to Source to Code, your magic decoder ring to demystify the jargon surrounding the technology industry. I'm your host, Ben Coffin, and join me each week as I try to dig into what these buzzwords are all about, how they're being used, and who actually needs them. We're back for part 3 of our first series here on season 1 of Source to Code, where we're trying to unpack the mystery of artificial intelligence. In episode 1, I spoke to Rahul Brito, a PhD student at Harvard University who's working with AI to analyze patterns in the human brain. And in episode 2, we caught up with Sarah LaSelva, director of 6G marketing at Keysight, about the role AI is playing in the wireless communications world. Now, if you want to listen to those episodes before you dive into this one, head on over to keysight.com/find/source to code, where you can catch up on all the episodes of Source to Code. And while you're over there, if you want to stay in the loop and get each episode as soon as it drops, join our mailing list so you can stay up to date on everything we've got going on here at Source to Code, including bonus insights on the guests and first looks at the tech we're discussing on the show. You can also be entered for a chance to win a Source to Code hoodie that we'll be giving away to subscribers on the mailing list at the end of the season. And of course, if you're on our site and you're perusing the All Episodes page, you can check out companion content for each week's episode. For this week, we've got the Want to Be Digital First ebook, which will talk through the workflow of hyper-automation, basically using AI and ML-based workflows to modernize testing with a digital-first approach. You can read this ebook and all the other content for each episode back over at keysight.com/find/source to code under the All Episodes page. As I continued the process of digging into AI, I was feeling like the hype around AI is a little bit earned to a degree. AI on the surface is this all-powerful tool that can solve very specific problems, assuming you have the time, effort, and data to get it to solve that problem. But that gap between the raw AI intent and that process of learning, getting the right data, and setting your targets on outcomes that can actually provide value as a tool seemed like the big delta between AI being this world-changing, incredible tool and AI just being another overhyped bit of tech. So I decided if I'm going to get answers on how you actually teach a machine learning piece of software to do its task, I better go to someone who knows the ins and outs of how that works. Jonathon Wright is that guy. Jonathon is the chief technology evangelist for technologies like artificial intelligence and machine learning, and heads up product engineering for Eggplant at Keysight Technologies. But he's not just a Keysight expert. He's given TEDx talks, is highly sought after in industry and AI consortiums throughout the world as a speaker, and he's even part of the bodies that make sure that AI does what they're supposed to do. So, armed with a vague understanding of use cases in hand, I set off to talk to Jonathon to get to the bottom of how you could teach and test a machine. I'll be right back with our conversation right after this.
Do you like podcasts about technology?
Like hearing from industry experts about the latest trends and developments in the world of cellular communications?
Want to stay up to date on the world of 5G and enjoy witty banter at the same time?
Then have we got a podcast for you.
I'm Dylan McGrath.
And I'm Jessica Vasos.
And we are the co-hosts of All Things 5G, the podcast that puts the G in 5G.
As in, gee, what a great podcast.
All Things 5G is the indispensable podcast for business leaders and engineers tackling the toughest 5G development and deployment challenges.
Each episode presents a deep dive into the technology, business, and policy issues surrounding a specific 5G topic.
Experts from Keysight Technologies and the industry at large serve as our guides through the evolving 5G landscape.
Check out All Things 5G on Apple Podcasts, Spotify, Google Podcasts, Stitcher, or whatever platform you use to get your podcasts.
All Things 5G is also available on the web at www.keysight.com/find/allthings5G.
Check it out today.
You'll be glad you did.
So, hey, Jonathan, thank you so much for joining me today. So your role, you're thinking about AI, especially in the context of software testing all the time. Let me start with kind of maybe a dumb question, but what's the relationship between software and AI? Is all software AI? When we think about, what a computer is doing in software, is that intelligence? Like, where does the line start?
Yeah, fantastic question. So yeah, I'm based out in Oxford, and I think you've probably guessed on the other side of the pond. And sometimes we try to put kind of locations down to say this is north, this is south. Where is the middle bit? And I live just a few miles away from a place called Bletchley Park, and if you know about Bletchley Park, it's where Alan Turing was part of doing and of course you've probably seen the Imitation Games.
Yep.
But part of it was they created something called the Turing test. And that Turing test was, is this system intelligent, right? So yes, if it can pass the Turing test, then in theory it's intelligent. Now, of course, it's very easy to, pass that test. And of course, that was created back in the 1940s. So, artificial intelligence, and most of his work, which he's published and actually is in the Bletchley Park Museum, talks about different ways of applying artificial intelligence, machine learning, and deep learning into kind of anything, hardware or software. Of course, now we've got to this point of, well, what is a narrow AI, and what decisions is it actually making within the software? And unfortunately, we're in an age of people just slapping on the title of AI, even to represent all of the functionality of the product, not just maybe a subset of a small function which may use some kind of algorithm that has been developed. So, I think there's a lot of kind of hype. We know this in the industry, but it's really important to understand that people are thinking about adopting AI in software. At the moment, I think there was a study done by Forrester which said that only 20% of organizations, software organizations, have actually, started using AI. And of course, the usual stat that says that 40% are wanting to use it within the next 3 years. Now, that's that willingness, but I guess taking that journey to become not AI ready, but more AI enabled with those kind of new capabilities is a journey that is above digital transformation or any other big, large organizational transition we've seen before.
And where does that start for folks? Like when they actually have to, they say, "Hey, all right, we want to apply intelligence." Where do they begin with that? Is that where we see the machine learning part of it? Is it a data analysis start, or like how does that ball start rolling?
Yeah, fantastic question. And it's kind of, I'm going to give a bit of example. I was working for the patent office, and the patent office in the UK said, when I joined there, they said, "Oh, 6 years ago we launched a website," and I was like, "Okay, fantastic." And they said, "And now you can download and print off your the PDF version of the patent application, and then just send it to us, either scan it in or send it to us by Royal Mail, and then we will read through it and file your patent." Now, to me, of course, every stage of that felt like an opportunity to not only, apply these kind of techniques, but, to reduce that kind of pain of the paper-based process. Now, maybe organizations, when they thought about digital transformation, was moving away from having, in that case, they had 150 patent engineers who were or officers who were responsible to go through this. And when someone said, "Okay, is this patent similar to another patent?" they would just skim through filofaxes of other patents to see if it was similar, compared to loading them onto a computer system, creating something as simple as a search algorithm, and then matching where there's familiarity. So, that Burberry pattern that you've got, is that close to anything else? And, these are great opportunities for things like computer vision, as you pointed out, things like machine learning, but you've got to kind of understand what the use case is in the first place, and what what the decisions are being done by the humans. So that, human augmentation is really the way to do it. And if you think about maybe how, cars have learned to drive for autonomous vehicles, is we start off with humans assisted, and then we start taking all that data. Once
Right.
we've got enough data, then potentially we can look at teaching the system to actually drive itself, which again is a bit of a party trick because it's autonomous. It's
Mm-hmm.
not connected as far as a Car2X or Infrastructure X kind of talking to the other car and telling it that it's a certain distance away. So part of it is we rely on one or two different ways of approaching something, not always applying AI is the right solution for every problem. If the decision needs to be done by a human, then it needs to be done with a human in the loop. So that human should be connected at the point they need to make a decision. But the rest of the time, we want to automate as much as we can. And of course, Keysight automation, it's in our
Mm-hmm.
DNA. So how do we move towards, adopting AI, building AI into our systems safely, responsibly, ethically,
Mm-hmm.
as well as, effective for our end customers?
See, that's fascinating. I want to dig in on a question I have in terms of like intent on the learning, but maybe just to back up for folks who maybe they, again, they're working in an industry where AI is adjacent to them. We talked about sort of learning and then the application and this idea that the AI gets better over time. Can you talk a little bit about sort of what that workflow is for training an AI and what is sort of the training part, and then what is it actually like acting separately on its own?
Yeah, sure. So again, it needs to have some type of reference, and of course, we do this for a lot of customers. So training data is absolutely critical. So, but when you're applying or you're developing algorithms,
Mm,
what you're looking at is things like unsupervised learning. You're trying to give it a goal, give the machine learning a goal to end up at a point where it actually it's rewarding the system to say that it's got to the desired end state. So part of it is you can, in essence, the unsupervised learning could go through hundreds of permutations to get to the point where it's successfully logged in or it's successfully registered, because part of it is you are rewarding the system for that particular flow that
mm,
it in essence is a black box. Part of it is a number of different states that it has to go through. So this is the same in essence for things like deep learning, where it kind of uses it. We use transfer learning to auto detect and clarify UI elements. That is reliant on us having a set of images that we can train our
mm,
algorithms for. So I mentioned the cart logo. If I
mhm.
put into Google cart, I might see a horse and cart, not just an icon from a shopping cart.
Right.
It has to be the correct context that it's doing. So training it on systems and frameworks like React and Flutter and all these kind of general software packages, training it on those kind of images that we see every day and different types of menus and icons, and using that as the source of truth allows us to create a robust and reliable AI computer vision engine, which can identify, and track objects in, near real time, and then
Mhm.
understand the context of them to say, okay, I've got a warning that's come up on my screen. I need to make a decision. That warning is telling me this user account has been disabled. Okay, I now know I've got to register a new account and activate that account before I can continue my journey. So it's complex, but in
Mm.
actual fact, it's based on principles and practices that the industry use for when they're developing applications with AI that feel like they're doing some kind of magic. And I guess that's the easiest way to summarize it.
Yeah, no, absolutely. Well, and this is perfect because what you just walked through, I think helps. One of the questions that I was going to have when you were early on, we were talking about, or in the previous question, we're talking about how these systems sort of are human augmenting or human. We set out and we give this problem to the AI that we want them to solve, and so there's something I'm kind of curious about on the, maybe the term is bias, but one of the examples that I've been fascinated by is this idea that, okay, we can train, there's you talk about the computer vision. You train an AI to discern the difference between pictures of dogs and pictures of wolves. You feed it thousands of images, and then it slowly figures it out. But when you go back through and it starts clocking huskies as wolves, it's because it's looking at snow and it's not actually looking at the dogs themselves. It's trying to figure out, is there snow in the background of the picture or not? And that has always led me to this question around AI, where it's like, how do we know that the AI is informed, like, with the right biases, if that makes sense? Like, how do we set the how do we ensure that where we're training the AI, it's figuring out what we want it to figure out?
Sure. I guess, I'll give a bit of an example. I was talking with a well-known VR headset, consumer VR headset company, and we were talking about using our computer vision engine, which we've got to recognize, within a gaming landscape, objects, and so, of course, within a gaming landscape, there's physics engines. There's reference models, which, whether that be a wall, or what a wall should look like, or a chair, or some type of door. Part of it is it has its own internal references in its own world. In this case, Unity framework. Part of it is we could train just on those, which is one source, which, in essence has a bias because it is just within their product. And it doesn't, of course, we want it to create a narrow AI that works with their product. But if they want to apply that more generally to other applications, maybe Stream VR or another development platform that has other types of augmented, mixed reality, or virtual reality experiences, how do we apply the algorithms that we've done and developed for a proprietary, gaming engine to apply more generically? And to your exact point, the Husky example is because it's using natural language processing, in the sense of an NLP engine is linking the context aware, that the image is found from the computer vision engine. So the computer vision engine said, there's a picture of a dog and a cat on a beach. There's a picture of a cat in the snow. Part of it is starting to understand context. Therefore, it starts making assumptions based on, this is a picture of a dog, or this is a picture of a cat. Now, we can overtrain our algorithms to kind of get rid of those kind of nuances out of the way so it doesn't spot wolf. However, what's saying that once the actual system that's being released into production doesn't change enough, that actually there is no longer any dogs, they are just wolves. Part of it is, the algorithm that you've trained against the training data that you've trained within the development environment may not be what the system is in a year's time, 2 years' time, 3 years' time. So part of it is we have to continuously evolve, but we also need to make sure that the data sets that we're using don't have a bias against one particular framework or one particular solution. It's actually more generalized. Of course, it's not general AI, but it is more, the misclarification rate is much lower in those scenarios where, there's a wolf, or within a mixed reality environment, or even if you're in, mixed reality with, Google glasses, and there's a wolf coming at you down the road, it highlights danger above it, would be a good suggestion. However, if there's a poodle walking down the road and the Google glasses also says danger, then obviously the AI is not doing what it needs to do.
I'm curious. I have a little bit of AI background. My background's in the wireless comms world, and there are existing sort of data sets that exist for researchers to be able to go and grab and then train their algorithms with. Where does someone that is interested in AI, like, where do they start with getting things like data sets to train? Is it all just like, I've got to, hope that our company has been keeping logs of everything we've been doing for so long? Are there open source data sets? Like, where does the data come from?
Yeah, so there's so many different references for data sources, but the one that I'd probably call out the best would be something like Kaggle, which started with a K. I'll make sure it's in the show notes. But Kaggle is a website that allows data scientists to come together to collaboratively work on large data sets. So when you enroll on Kaggle, it gives you my favorite Titanic
Hmm.
example. And there's a lot of bias within that kind of assumption, should we say, that the people who were upper class or first class had a higher level of survival than they did
Yep.
in the bottom classes. But actually, that isn't true. So the data sets which they have, people challenge each other to identify, to create more realistic models of what actually happened, to the point now where the top 5 or 6 contributors are to the point where they've identified everybody who made it out, everyone who didn't, what age they were, and able to
Hmm.
simulate that based on health and location and proximity at the time on the boat. So there's a large community sets
Wow.
of data that's in there, which is fascinating. But straight away, our bias applied to it as a developer is like, well, it was just the poor people who sang, right?
Right.
Part of it is, we come in with this viewpoint that is what we believe. Therefore, sometimes we end up developing what we want as an
Hmm.
outcome. And Steve Wozniak came on last year. He did a session for us when we were launching the Salesforce Accelerator, which was this tool which automatically went through, learn your entire Salesforce instance and how you configured it and customized it, and then it autonomously generated all the different tests that were unique for your organization. It created a kind of a digital twin of your unique Salesforce instance. And
Hmm.
when I was chatting with Woz prior to that, he kind of mentioned, it's really important that we focus on this explainable AI. We were able to explain to other people what our solutions are actually doing and what makes them a feature, and that is the kind of the magic. But it's also kind of explaining it and how it works so that people can understand it. And then if it
Right.
doesn't work, then or it digresses from working, then people can identify that a lot quicker.
Yeah, and that's the explainability of it, I think, is really key. When you think about the application of this technology at a broad level, like, Terminator movies have made us all a little afraid of where the computers are going to go, and this notion of artificial intelligence, because of Hollywood's done a great job making it a great bad guy. So, in reality, when we're utilizing AI, there've got to be some bounds, right, on what we can and can't do. What is it that we can work with when it comes to artificial intelligence, so that we're careful with it?
Yeah, so this is an interesting one. My friend Davey used to work for the Pentagon, and he created a company called Calypso.ai,
Mm,
which was paid for by the administration to look at whether or not an AI has maybe gone rogue. To your
hmm.
kind of Skynet example, and he would go around looking at healthcare, pharmaceutical companies that had adopted AI and machine learning, and he'd go and understand that actually, he never come across anything that was dangerous because they were all very primitive, or they were
Mm,
all just for loops that was kind of smoke and mirrors of it's still in essence programming.
right.
It's not, there's no AI within the solution, and demystified it, should we call it.
Mm,
But I sit on the European Commission AI Alliance, and we actually put out a paper. Well, it's just a standard now, which is it's a high level guide around ethics for AI. Um, and you can go on there and download it. And actually, the BCS and the ISO managed to put out a AI ethics guidelines document, which will be enforceable. And partly the reason that's happened is, yes, we've seen things like the Great Hack, and we've seen maybe how our data's been misused over time. And we've also seen companies like Google, who obviously have led the way in this area, lose and disband some of their anti-evil teams,
Right.
who literally were there to ensure that what they were doing was ethical, it was responsible and sustainable, and it was doing it for the right reasons. And just last week when I was in Stanford with Dr. Poppy Crum, who's a neuroscientist professor there, she was talking about exactly this: is are we building these kind of capabilities for the better of mankind, or to move the industry forwards, to improve on efficiency issues that we've got, to reduce waste, and whether that be manufacturing waste or carbon. Are we doing it for the AI for good, or are we potentially the use cases that we're creating actually negative to society and not sustainable? And therefore we need to at least be accountable as an organization, but we also need to follow the guidelines that are being given and adopted internationally, to understand where the limitations go. Now, of course, the singularity, and when I did my TED talk on cognitive learning, part of it was, okay, at what point are we going to get to a point where it's a Skynet kind of scenario? We all know that's a long way away. And yes, general AI is something which is something maybe we're working towards. But in actual fact, as we take that journey, we've got to be extremely responsible for it. And things like I read a book on the flight back on Digital Life 2.0. Part of it is you've got to understand, well, what are the applications that you should use AI for, and what are the applications you shouldn't, and what data should you use, and what data shouldn't you use. And I think that's a lot of it's common sense. But still, it's really important to put that out there.
No, that's actually really interesting, and I think that the that notion of where do we use it and where don't we, I think if you're someone on the outside of this industry looking in, you may think that we're applying AI everywhere, but I think that there's a time and place for it as a tool, right? It's a tool that we want to use in the correct situation, and there's responsibility around that. So I think that's an interesting thing that, frankly, I hadn't really put much thought on, but I like it a lot. Well, awesome. Well, thank you, Jonathan. I appreciate you talking with me today. I think this is we've got a lot of interesting stuff around hopefully demystifying AI to folks, and it's been a really great conversation.
Wonderful. And I might see you, Ben, in the metaverse or whatever. Once this is launched, we don't know what the future is going to bring, but I'm sure Keysight and Eggplant are going to help build and test the next generation of those systems.
Absolutely. I can't wait. I'll see you in the metaverse. After talking to Jonathan, it felt like the world of AI had begun to look a bit more clear. Artificial intelligence has the power to analyze like nothing before, but it's a process. It takes good data, but also good failures, and a significant amount of preparation to get an AI to do what you want. It took me back at the start of this journey with Rahul, where when we talked about AI, he told me, well, it can give me what I want, but for starters, it's just a way of sifting through too much data. At a point when your AI is just a sieve sifting through and hoping to find nuggets of gold, it's at the very infancy of its capability, and that's what I began to realize. When you give it experience, information, repetition, and test it to make sure that it does what it's supposed to, then it starts becoming limitless. Since recording these interviews, AI has made its way around the internet, a chatbot called ChatGPT. It was actually shared with me by Daniel Bogdanoff, who runs Double E's Talk Tech, and he was saying how it was writing code for him. It was actually like generating pretty good code right out of the gate. So I decided to check it out. I played around with the tool and had to create everything from taglines for this podcast. Now, for the record, I still liked mine better. To recipes for food and cocktails. I even used it to help me write my Dungeons and Dragons campaign. For the first time, I felt like I was getting a glimpse into the future that we heard about talking to the experts on this show. An artificial intelligence that's augmenting human capability, making everyday complex tasks just a little bit easier. All right, now that's it for this week on Source to Code. Join me next week as I take a dive into the world of digital twins, digital models fed with real-world data that help us to innovate faster. I've got a whole new series of guests, and this technology is an exciting one to break into. Now, again, if you're enjoying the show, give us a like, a follow, a thumbs up, whatever it looks like in your podcast app of choice. We really appreciate it. It does wonders for the show. And if you're jonesing for more, you can always head over to keysight.com/find/source to code, where you can find all the episodes, the bonus content, and be sure to join that mailing list. Thanks again for Jonathon Wright for coming on the show. Our conversation actually went way longer than what you heard today. So speaking of that mailing list, be sure to hop on that so that you can access our full conversation after the season wraps. I'm Ben Coffin. This has been Source to Code. Thank you so much for listening. See you next week.